Hi there, I'm back. Today I'm with 50 applications managing strategies. See here 50. Why this is for 50 applications? In the interview, at a medium or the large project, you have to say that I have managed 50 applications like that, around plus minus. So 50 applications, this is large scale, and you must have to know the strategies first. Strategies, then your hands-on, and most of the peers they said me to make some kinds of video, because as a senior DevOps engineer I have some expertise about this. So I added some very much important to manage the 50 applications around the strategies. I made this script. Actually, I made this script maybe more than 1 month. I just accumulated or aggregated some informations, then I have made this one. This is a DevOps project I made like this, and it will be with Terraform, Kubernetes, Ansible, Prometheus, Grafana, Elastic, Logstash, Kibana, ELK, AWS resources like S3, RDS, EC2, application load balancer, auto scaling group. So if you put this line or this sentence that in the resume, I managed 50 applications with, I managed then with Terraform, Kubernetes, Ansible, Prometheus, Grafana, ELK, and AWS resources. It will be very much strong, your resume, also in your interview. So I prepared this one to speak up, in the interview. Interview is like a project yourself. No need to be hurry, no need to be rush. Take deep breath and explain small. Make the small bigger. That is the interview for you from your side. So I made this one, the whole strategies in the brain first, then how to speak up, how to deliver the interview. I think you guys will like this one. Please leave the comment. Okay, listen. Yes, the project description is like that. This project will demonstrate how the how to manage, provision, deploy, and ensure high availability for 50 different applications using a combination of tools and platforms like Terraform, Kubernetes, Ansible, Prometheus, Grafana, and ELK stack. It will also involve AWS services like EC2, S3, RDS, ALB, ASG, and Identity Access Management. And the focus will be on automating deployments, scaling applications during peak and non-peak hours. Guys, this is the bullet words. Peak and non-peak hours. So, why you will be hired? You will be hired to managing the applications, to automating, auto scaling like that during the peak and non-peak hours, load balancing traffic, ensuring secure access, ensuring and monitoring the performance. When coming the word monitoring, always say the performance. Monitoring and performance, these two guys are like brothers. Then tools and technologies. Here I have used the Terraform, Ansible for configuration, Terraform for IAC, Kubernetes for orchestration and monitoring, Prometheus, Grafana, logging, ELK stack, and AWS services. These guys I have used here. Security IAM roles, security groups, network SLs, and CI/CD Jenkins for automated builds and deployments. Okay, then architecture overview. The architecture includes 50 microservices based applications. When you're saying that 50 applications, remember also say that microservices. because monolithic can't be like too much. Monolithic will be just shrink altogether, coupled, not decoupled. So when decoupled, then number is more. So 50 when saying the applications, then also says the microservice based applications. I deployed on EKS, and say I, not we. In the interview say I deployed, I configured, I automated. Okay, on EKS, then EC2 instances as nodes. EC2 instance in the AWS, Kubernetes knows as the nodes. EC2 instance actually the nodes for the Kubernetes when this is used in the EKS. This is tricky. And the Kubernetes cluster with auto scaling for horizontal scaling. If calling the cushion for horizontal scaling, it's coming the auto scaling always. RDS for database of each application with replication for high availability. When coming the high availability, RDS giving the replication easy. Also S3 cross region replication. CRR. So replication, that means here is one instance and another one is replicated to another edges or another regions. Like that, this is high availability. If unfortunately this instance is broken or cracked, then we have another one in the another edgy availability zones or regions. There is the replication. Then S3 bucket for storage of static content and application backups. So what is the EC2 nodes RDS database with application? S3 bucket storage for static content and application backups. S3 bucket not only containing the static applications or anything else, it's also working as the backup. Then application load balancer ALB for distributing traffic across multiple application pods and EC2 instances. So load balancer is distributing the traffic. It's multiple application pods. When coming the multiple application pods and EC2 instances, then the question of load balancer, because load balancing not for the one application pods, one EC2, it should be multiple. Then Prometheus and Grafana for real-time monitoring. Then ELK stack for centralized logging and troubleshooting. Centralized logging and troubleshooting. IAM roles for secure access control between services. So yeah, this is the overview for 50 applications. Guys, please try to memorize. I am not saying memorizing everything. Do some hard work. Specifically for the new guys who are watching, please try to memorize this paragraph. I think take the screenshot and please try to memorize this one. Project steps here: infrastructure provisioning with Terraform, tools, Terraform, AWS resources. These guys create a VPC with multiple subnets. Subnets will be multiple, public and private. Public must also private across multiple edges for high availability. When you making the high availability, that means you have the multiple subnets. So without multiple subnet, it can't make the high availability over the edges. Subnets actually representing the availability zones, the routing, this way, that way. Yes, then provision EC2 instances as Kubernetes worker nodes with auto scaling groups. Okay, for horizontal scaling, set up RDS with multi-edge replication for the database of the application. Create S3 buckets for storing application artifacts and backups. Terraform configuration, vpc.tf. So when I'm making the Terraform configuration, file is .tf. Okay, define the VPC subnets internet gateway, ec2.tf. So EC2 has which one? Instance, ALB and ASG. RDS.tf. Define the RDS for database with multi-AG for high availability. S3.tf creates S3 buckets for storing backups and artifacts. Terraform CLI commands. This is the CLI commands. So Terraform init, then Terraform plan out equal infra plan, or just if you write the Terraform plan, that's also good. Then Terraform apply infra plan, you can specify like this. Okay, then Terraform part is finished. Then Kubernetes cluster setup with EKS tools, EKS Kubernetes Terraform. Use Terraform to provision an EKS cluster. Configure EC2 worker nodes to join the EKS cluster. Set up IAM roles for each communication between applications and AWS services. Terraform configuration for EKS. So EKS.tf, it defines the EKS cluster, node groups, IAM roles, and networking components. So it has the node coming with groups. I am coming with roles, not user. Be careful when creating the EKS. I am coming with roles. Then the networking components are coming. Node coming with groups, because just one node, this is not the cluster. Cluster should have at least 2, 3, 4. Moderate is 4 nodes we are using at least. This is the industry practice. Then Terraform CLI commands. Create EKS cluster, Terraform apply hyphen target equal module.eks. So when I am applying the only one module, then this is the command Terraform apply hyphen target. You have to target the one module. When you're targeting just one module, then like this hyphen, then target equal that module, then .eks like that. Then update kubeconfig. You have to update kubeconfig, AWS EKS update kubeconfig hyphen region, US East 1 or anything else, then name my EKS cluster, whatever the name you have to write here. You have to update kubeconfig. Why? Because you have to connect. When updating kubeconfig, this EKS cluster is connected with your local one. So kubeconfig for the updating local machine to the cloud is connecting the update kubeconfig. Then verify nodes in the EKS cluster. kubectl get nodes. So after having the node, you must have to verify. Then application deployment using Helm and Kubernetes. So I am doing application deployment using Helm and Kubernetes. Tools Kubernetes Helm Docker. Use Helm to deploy 50 different applications, microservices on the Kubernetes cluster. So I'm using Helm to deploy, guys, remember, Helm to deploy 50 different applications or microservices. 50 lots, all right? So interviewer may asking, so 50 microservices you deploying with which tools? Say that I am using Helm to deploy 50 microservices on the Kubernetes cluster. So remember, when you saying that deploying, then which place, man, you deploying? Say on which one? On any cluster. Maybe this is the cluster. You're deploying 1, 2, 3, 4, 5, 6 like that, 50, right? So cluster, this is the cluster. So you have to have like that large scale cluster has only the Kubernetes in the market, honestly, like that very large scale. Then also Docker Swarm is working, but Kubernetes is very much popular. Each application will run as a Kubernetes deployment with associated services and horizontal pod autoscalers, HPA, horizontal pod autoscaler, associated services and horizontal pod HPA to scale based on CPU uses. Based on, so HPA, horizontal pod autoscaler, is always keeping an eye to the CPU uses. How much CPU is consumed. Then application categories, backend services for data processing using languages like Python, Node.js, Java for the backend. Front end, which one coming? React, Angular. Data processing, which one coming? The application, the batch or real-time processing with Kafka. So you can use that batch or Kafka. Kafka is very much popular if you learn very good. Then machine learning models for real-time prediction services. Machine learning how's doing prediction. Sometimes the interviewer is tricky for the senior level, maybe asking, are you using any tools for the prediction or any models for the prediction services? So they are not saying directly for ML, machine learning. So if you are for the senior level, you must have to know that prediction service, which one, prediction word, which one implying. Then you have to say that yes, or you have to say that maybe like that. But yes is better. We are using machine learning models. I am also part of that. That's it. Then sample Helm commands. Install backend services. So when you're doing the backend service installation, Helm install backend service like that. So installing anything else with the Helm is coming first Helm install, then coming anything else backend service space dot, that means everything slash Helm backend like that. Then install front-end service, same way Helm install coming, then coming front-end service space dot slash, then Helm front-end. So it is going to the here. Then set up horizontal pod autoscaler, that means SPA. How to set up the SPA? kubectl autoscale deployment backend deployment hyphen CPU percent 50, then min 3 max 10 like that. So this is for the HPA. Expose, after setting up the any kinds of pod like this, then you have to do the expose. I'm making underscore. Then services using the load balancer, kubectl expose, kubectl autoscale, kubectl expose deployment frontend deployment type load balancer name frontend LB. You can give any kinds of name. I'm not making this one like this. Okay, then configuration management with Ansible tools, Ansible EC2 S3 RDS. Use Ansible for automated configuration of EC2 instances and managing static content backups for S3. So Ansible for automated configuration of EC2 instances and managing the static content backup. Then configure RDS to replicate across multi-AZ for replication database. Ansible playbook for EC2 configuration. So please guys, try to memorize any one playbook. I'm not saying to memorize this one, I'm saying to memorize any kinds of playbook in your brain should be had like that, any kinds of model playbook, you know. So here is one of the playbooks. Name here playbooks is start like this, always hyphen for Ansible for YAML file, then name colon configure EC2 instance. Interesting something, you think that configure playbook can read like that and playbook really configuring. I like Ansible for many things, but this is one of the matters I like. Ansible is human readable. If you say name I want to configure EC2 instance, okay, Ansible will do that. You can write here. Then host EC2 underscore instances, then task. Playbook has task. That means playbook playing with tasks. At least one task, 2, 3, 4, multiple tasks you can use there, and playbook just playing with that tasks. So I just memorize like this. The task So name here install docker. See here you saying install docker, so playbook will install that one rightly. So apt command is like that, name docker, state present. Playbook needs to have the state present or absent. Normally present, because you need to have like that. If not have, if no need, then you need to write here absent. So task has name, then the command apt, then name docker, then state. If in the interview if you say that task has name, command, then state present, that's fair enough. The name install nginx for front-end load balancing. You said here configure EC2, right? You are saying here install nginx. It will install automatically. apt command it will take. Then name nginx state presence. So there Ansible playbook for S3 backup, name backup application data to S3. Ansible listening, host all. Here see we define host here EC2 instances, but here S3 we given the host all because all kinds of data we need. Then task, then name copy files to S3. So it's making a copy from maybe any kinds of resources. AWS S3 bucket, you giving a bucket app, then backups, any name, object data backup dot tar dot js. So object will be like shrink, that means dot tar dot js, making very light. That means this is not elaborated. It will make 10 GB to 10 byte, like that, very small. Then source var app, this is the data backup, this is the data backup, object data backup dot tar dot js, this is the source. Mode is put. So see here interesting something, this mode is put. Why? This is like API command, put get, so put means here post, so you have to post here. Interesting, really. Ansible interesting. Run Ansible playbook, then after having the playbook, Ansible hyphen playbook, then hyphen I interactive, then inventory, then ec2 hyphen config.yaml, like that. Then s3 backup.yaml. So after having this, you must have to memorize this until Ansible hyphen playbook, then space hyphen I, then space inventory. Just memorize this until then ec2 s3 rds, anything else may be coming. Then monitoring with Prometheus. Guys, interesting something, the Ansible part started here, right? So if you learn Ansible from here, I'm saying something interesting. Oh, it's coming all. Okay, making it smaller. So Ansible playbook from here, and just finish the Ansible running the playbook is more than enough, I think, for your interview. Any kinds of Ansible. If you just explain like this, I'm using Ansible playbook first, I'm writing like that, then I'm creating the playbook for each S3 EC2 RDS like this, then I am just running the playbook like this, Ansible hyphen playbook, then space hyphen I interactive, then inventory, then my ec2.yaml, then s3.yaml, like that. That's fair enough. Then monitoring with Prometheus and Grafana. Tools: Prometheus, Grafana. Set up Prometheus for monitoring Kubernetes clusters and EC2 instance metrics. Use Grafana for visualizing the performance of the application. So when coming the monitoring sound, then also the performance. Helm command to install Prometheus. Helm install, this is the basic command, Then Prometheus hyphen community, this is the Prometheus which one now we are using. But Prometheus installing command, helm install Prometheus, you must have to write like that. Then the community version on or the location like that is coming. Then Grafana dashboard setup, access Grafana, kubectl port forward, SBC service slash Grafana 3000 colon 80. That means 3000 is for the front end port normally. So Grafana, the port forwarding I'm doing from 80 to 3000. Which one my expected port forwarding, that one is first, and which one is existed, that one is last, colon then last. Existing is 80, but I want to see the Grafana at 3000, or I want to see Grafana at 3001, like that. You can write like this way. We do sometimes like this way, 3001, 3002, like that, or 3011, like that. And Prometheus as a data source and import a pre-configured Kubernetes dashboard. Prometheus is the data source. Source. Which one source? Data source. So Prometheus is like the S3 bucket to me, okay, for Grafana. So Grafana, Prometheus, these two brothers or sisters. So if you think that Grafana is the sister, then Prometheus is the big brother. Prometheus giving the data, all the data, and sister just displaying Grafana. Then logging with ELK stack, Elasticsearch, Logstash, Kibana. Tools used: Elasticsearch, Logstash, Kibana. Use ELK stack for centralized logging of all the applications. Logstash will collect logs. How's collecting logs? Like Prometheus collecting the data for Grafana. So here Logstash will collect from Kubernetes pods and EC2 instances, sending them to Elasticsearch for indexing. Collecting, Logstash here is the big brother. He is collecting all the logs from EC2 or S3 or RDS, any kinds of from the pods, then is sending them to Elasticsearch for the indexing. Elasticsearch making the indexing. That means making the shelf one by one. First shelf, second shelf, third shelf, fourth shelf. So taking the logs from Logstash, Elasticsearch making the shelf or indexing. The word is here in the industry is the indexing. Then Kibana will be used to visualize logs. Kibana is the sister here. Kibana has just the visualization dashboard. Guys, please memorize. First is the Logstash. Logstash collecting from lots of sources, lots of multiple, and then is coming to Elasticsearch. So how can I say? If the Kibana this one, then in between Kibana and Logstash there is the Elasticsearch. Elasticsearch just indexing. Learn one time, use lifetime. This is my slogan, or this is my word sentence for the DevOps learning. Just learn one time, use lifetime. DevOps is easy, guys. Okay, please just do hard time first, then life is easy. Any kinds of problems coming, nothing is hard for you then. Okay, helm command to install ELK stack. So ELK stack helm install Elasticsearch is coming first, of course, for the Elasticsearch installation. Then this one, then install Logstash, helm install Logstash. So just memorizing first. I said earlier also, helm install, then which one, then the location. That's it, like that. Kibana, same thing. Helm install Kibana, then Elastic/Kibana. Then access Kibana, kubectl port forward service/Kibana, like this. Here is Kibana 5601, the expected, but existing is 80. So from 80 we are taking to port forwarding 5601. See here, Kibana is existing is 80. Also here, see something interesting. Grafana also existing is 80. So I made this 3011 different port forwarding, and also here for the Kibana 5601 I have taken. You can take anything else. You can take 1001 like that. You can take 22, not 22 actually 1022 like that. Just 4 is good industry practice like this. Then auto scaling and load balancing tools, AWS LB, ASG, Kubernetes HPA. Then configure application load balancer LB in front of the applications to distribute traffic, and auto scaling group ASG for EC2 instances to scale based on CPU utilization and traffic. Terraform configuration for LB and ASG. LB.tf defines LB configuration with listener rules. ASG.tf for auto scaling groups to scale EC2 instances based on the load. Auto scaling policies scale EC2 instances based on CPU. So CPU utilization and CPU uses, guys, very much important. I will make one more video I think for the CPU uses. This is important very much in depth, because CPU uses actually DevOps guys sparse to make the auto scaling policy. So CPU uses leads to the policy. So CPU uses is not too much. You don't need to make the policy like that. Auto scaling out. So CPU is too much when coming, when your end user too much, maybe 1000 to 1 million. So just burst should be. It's called burst out. Okay. Then AWS auto scaling. This is the CLI command. Put scaling policy, auto scaling group name like this. Policy name. You can write policy CPU auto scaling up like this. Adjustment to adjustment type, change in capacity. This is for the CPU CLI command for the CPU uses. Then security with IAM roles and network policies. Tools AWS IAM. Then Kubernetes network policies. Configure IAM roles to restrict access to AWS resources. Use Kubernetes network policies to control traffic between application pods. IAM role creation. Here is the AWS IAM create role name. Assume role. Okay, this is interesting. You are assuming role policy. Then document. So assume, I don't know why Amazon using the assume, because you're creating the role, but you must have to write here assume. This is the CLI command must be. Okay, then trust policy.json. No need to memorize this, guys. Okay, just I am AWS I am create role, then assume role. If you say like that in the interview, fair enough. Then Kubernetes network policy. I have made one, this one, API version always coming, then kind, which one, Kubernetes. When Kubernetes is coming, that means the YAML file, you know, right? So API version kind, network policy. So here is the metadata. Kind is followed by metadata, is followed by name. That actually just nothing else, almost the name. Restrict traffic like this. Then spec, port selector, spot selector, match labels, app backend, policy type, ingress. This is the ingress one. So ingress means inside, going inside, from port selector, match label, application front end. Okay, no need to memorize whole thing, just memorize this left alignment. Which one left alignment? API version, kind, metadata, spec. This is the 4, right? Then specs child is this one, grandchild, grandchild, child. This is the child, right? So spec is the much bigger portion actually. Spec has lots of things, the description. So spec just know what kinds of kind. This is the network policy. So spec is just defining inside which one should be working, that like port selector, policy type, ingress. Just some, you can memorize something, not everything. Then CI/CD with Jenkins. Tools used Jenkins and Kubernetes. Set up Jenkins to automate the build and deployment pipelines for the applications. Vim Jenkins file. This is in the Groovy language. I made this one smaller, but I'm making this one bigger for you guys. Okay. So Groovy language Jenkins, when coming the pipeline is coming like this. Pipeline is the father or grandfather. How many stages? So here is the one stage build and the stage deploy. I have used just build and deploy, two basic stages. So here build and then steps. Any stage has the steps. Here is the shell command, ambient clean package. Then stage deploy steps, shell command kubectl apply -f, then the deployment.yaml. So kubectl apply like that. The project outcome, after this project 50 applications are deployed and managed with high availability and scalability. Terraform provisions and manages infrastructures resources in AWS. Kubernetes orchestrates containers, ensuring easy management and scaling. Prometheus and Grafana monitor application performance in real time. ELK stack provides centralized logging for troubleshooting. Ansible automates EC2 configuration and S3 backups. Guys, I'm saying again, please try to memorize this outcome. Also, I said, I think at the starting, same thing mimicking again here almost. This will be really your gold or diamond, I think, for the interview. Any kinds of interview, just say, I deployed 50 applications. I managed with high availability. I used Terraform to provision like this. I used Kubernetes for orchestration. I used Prometheus Grafana for monitoring. I used ELK stack for logging. I used Ansible for configuration management. Oh, man, you must get job, okay? No worries. Then conclusion. This project demonstrates a full-scale production-ready environment. Production-ready environment suitable for modern enterprise application with strong DevOps automation. Yes, guys, I think it will be very much helpful for you guys. I am suggesting to watch this video again and please try to memorize like this one or this one, same thing almost, or the conclusion before. Please try to memorize for your oncoming interview. If you are new or you are the senior level going to be interviewed, it will be helpful very much, because here is, see here, 50 applications microservices you are managing, man. You are not a small guy or something new guy. When you saying that 50 applications, 60 applications like that, oh my goodness, it's huge. I hope this video is helpful to you guys. Please leave the comment. Yes, this is night time here. Thank you very much. Have a good night.